Okay, maybe I'll start. I'm to preface this. Okay, if I were to go down to my home country, South America, if you have a million Guaraníes, that's the currency there. It sounds like a lot, right? I've got a million, but you know what? It's only worth 200 bucks, right? So, but if I say I have a million and somebody in a different country has a different currency, it's like, oh, I've got 2 million, right? You might think, oh, the one with 2 million obviously has more money than the one with 1 million, but they're different currencies, right? It's actually not quite accurate. You have to standardize it. You have to convert both currencies maybe to Canadian dollars, and then you'd be like, well, now I know for sure who's doing better. That's what we're going to contemplate here. We're going to talk about how to standardize everything. Okay. So there's something called a standard normal distribution. Okay. And in a nutshell, what we're going to do here, before I just talked about normal distribution all the time, normal, normal, normal. Now we're going to add the word standard. Maybe I will just underline, right, the fact that we're now talking about standard. So we're using z-scores to compare data from different sets. It's almost like your different countries. So here we go. Jay's final score in his class was 70% with an average of 75 and a standard deviation of 5%. Jasmine's final score in her class was 60% with a class average of 65 and a standard deviation of 7. Graph a normal distribution curve for both classes. So that's what we're going to do now. Okay, let me just get this figured out here. Okay, so if we go with J, okay, J's class, we're going to do that here. We know that right about here, this is the average. This is 75. So we're going to make a bigger mark here and say this is 75%. Somewhere in the middle, one of those longer lines. And so we know that the standard deviation for J's class is 5, correct? So I'm actually going to use this as my scale here. So I'm going to count 5. 1, 2, 3, 4, 5. That's 80. That's one standard deviation. And another 5, right? That's 85. And another 5. That's 90. That's good enough. Then I go back 5% going this way. This is 70. Going back, that's 65. Going back another 5. That's my standard deviation is 60. So this is actually drawn to scale. Let's go with Jasmine's class here. Jasmine on the other side. Jasmine's average is 65. Oh, sorry, a mean for the class. So we go 65 in the middle. This is the mean. And it's 7. We have a standard deviation of 7, right, for Jasmine. So we're going to count 7. So 2, 4, 6, 7. So that would be 72%. We count another 7 there. That's 79%. We count another 7. 2, 4, 5, 6, 7. Sorry, I have to extend it a little bit. That would be 86%, right? And let's go 7 this way. So 2, 4, 6, 7. I'm going to make that marking there. And that would be 58%. Let's count another 7. That'd be 51. And another 7. 2. That'd be 44%. So you can tell that Jasmine's class is spread out a bit more, right? Because that's the standard deviation of 7. So let's make one point clear. Which one is going to have a steeper curve between these two? Which one's going to be steeper? Higher up. The smaller standard deviation is going to be steeper. So J has a smaller standard deviation. So we're going to make that one a little higher. And then we're going to go over to Jasmine and just bring that one slightly lower. Okay, so it's always around the mean that we're looking at. So let's draw J's curve like that. Beautiful, right? Where is J located in his curve? What's his final score? 70%, correct? So this is J right here. So his class is a completely different set. It's almost like a different country. And then Jasmine, hers is 60%. 60% is actually right here because we drew this to scale. We can actually pinpoint exactly. It's right there. So we're gonna now, I don't expect you to graph the curves every single time, but it's just for illustration purposes. So we'll calculate the z-score for each student. So z-score for J, that would be score minus average over standard deviation. So that'd be 70 minus 75 over standard deviation, which is 5. 70 minus 75 is -5. Divided by 5, we are at -1. That's J's z-score. JZ. We could even add some stars in here. But it makes sense that J is like, he's below the average, and actually a full standard deviation below the average. So how about Jasmine? We're going to go actual score minus the average divided by standard deviation, which is 7. That's -5 over 7. That's -0.71. What in the world does this tell us? Okay. Well, who is closer to the average actually in this case? Jasmine is, right? Slightly. Because J's z-score is a full standard deviation to the left, whereas Jasmine is just 0.71 standard deviation to the left. Okay, so we would say, let's just keep going. I will give you the visual on that curve below. Graph a standard normal distribution. We're gonna highlight that. It is similar to normal distribution, but what's the difference here? Only has z-scores along the x-axis. That's the difference. That's what a normal distribution curve is. A standard normal distribution. Okay, I'm going to circle this whole thing here. So here we go. So that would mean that the middle, I'm going to pick this as my middle here. It's going to be 0, and then I'm going to have 1, 2, 3 going positive, and -1, -2, -3 going into the negatives. These are my z-scores. Okay, so we would still go to the top here and just make our curve, our bell curve. And now we're going to put both of these on the same standardized normal distribution. So we know that J is right here, and Jasmine is 1, 2, 3. This would be 0.6, so 0.71 is right about there. Since we're talking about scores, the higher on the bell curve you are, the better you did overall. So if you had like 5 students being compared and you plotted their z-scores on here, the one that's higher up is the one that did better overall. Okay, so we're gonna say this: since we are talking about uh, final scores, a higher z-score is more desirable. Jasmine's final score may have been lower, but her z-score places her above J. Okay. So it has to do with the average. Some of the reasons why you want to do the z-score. You might have a teacher, right? One student may have a teacher that's very easy at marking. It's like, oh yeah, here you go, 90% every single time. So you look like you did very good compared to your classmate who had a different teacher, just super strict. Every time you made a small mistake, just -1, right? And you're like, I got a 60, you got a 90. What's up with that, right? You can't really say I did better because I got a 90 if they're different teachers, different classes, maybe even different schools, right? So a z-score considers the average of that class, right? The particular class, and then you standardize it. You bring everything onto the same standardized normal distribution. And you do that by calculating z-scores. So what you ask your friend next time is like, can you give me your average and the standard deviation for that class? I'll get back to you, right? And then you're like, wait a minute, I actually did better than you overall. If you actually happen to have a higher z-score than your friend, okay? So that's what it is. That's how you do it. So this is the concept that was on the AC that I just omitted today. Okay, so this is one of the concepts I need you to understand. And yeah, I'm going to talk about one more thing. So come with me. This is going to take you to 51. Page 51. Okay. One of the last concepts before, so basically after this, we're basically done before the test, okay? Determine the mean and standard deviation by hand, okay, without using the TI. So here's some of the things that I need you to remember, okay? When we're given limited information about the data set, okay? Only values are given, right? Only 2 values are given, I should say. And the question often mentions the percentages of the values located between them. And then I'll use a different color. Sometimes it'll give you the associated z-scores. Okay. if 60, like if a question says 68% of data points fall between the values, if 68, that should ring a bell. That means plus or minus one standard deviation. Okay. So that means that there are two gaps between the values you're given. And you're maybe wondering, two gaps, what's up with that? Why did you say that? Well, look at this. Plus or minus one standard deviation. If this is the mean, it takes you from here to there. How many gaps do you have? Right? If you count from here to there, it's 1, 2. That's why I came up with two gaps. I will actually use pink just to get me from there to there. Okay? If a question mentions 95% of data points fall between the values we have, then we know if it's 95, you should be like, oh yeah, that's plus or minus 2 standard deviations. That would be the equivalent of 4 gaps being in between those two values. So that would mean we're considering everything from here to here, and that is 1, 2, 3, 4 gaps in between those. Okay. Last but not least, if 99.7% of data points fall between the values that you're given, I'm going to use green for this one. That is plus or minus 3 standard deviations. That gets you from here all the way to here. And to get from one to the other, you would have to say that there are 6 gaps between. So there's 6, 4, and 2, basically. So it's important to know like how many gaps are in between, and you just have to remember it's the 68, 95, 99.7 that we're going by. Can I just say one more thing? 99.7 is the majority or in general. Can you write that down? If a question says in general, you know, males are between 165 and 178 centimeters tall, you know it's referring to 99.7, which is basically 6 gaps between there, 6 standard deviations. So this is a reminder that, you know, this never goes away. It stays with us. Okay. And these are the two formulas that I will encourage you to have on your study sheet. One is to calculate the mean, right? To calculate the mean, and this is to calculate the standard deviation. And I'll show you what I mean by, I think this is all it just self-explanatory, right? Like the x is the value considered, and standard deviation, and z-score. Okay, so you will know all of these things. Alternatively, to find the standard deviation, we'll go upper value minus lower value, and then z up minus z low. So these are z-scores. Okay. This and that are z-scores. And let's try a few questions before we dive in. So using those formulas, let's answer the following. Here we go. Let's go to 52. I will just say this, you will recognize this type of question. You won't know the mean and the standard deviation, so you can't use normal CDF, you can't use inverse norm. Like it just doesn't work because you don't know those two things. So grab a highlighter And let's just go through this. A farmer fills bags of potatoes in order to ship them to a local market. After weighing all the bags, she finds that, what's that? 95% of bags weigh between 56.4 and 65.6 kilograms. In this course, after having taken this course, right, you should know, oh, 95 means something to us here because I recognize it from the 68, 95, 99.7. And we have our upper and lower values. Assume the distribution is normally distributed, right? The weights are normally distributed. Determine the mean weight of the bags. Okay, so here we go. I will preface this. Preface. We can't use normal CDF or inverse norm since we don't know mean or standard deviation. So you can't use that if you're tempted, because I can see you going through the test and be like, oh, normal CDF or inverse norm. You don't know what the mean and the standard deviation is, so you're told that you can't do that. And you don't have a whole whack load of data points or a frequency table. Okay? I will do this since we don't know, and also we don't have many data points or a frequency table. We don't have that either. So then you know you're in this category right here. So to find the mean, can I find the mean right off the bat? Let's try it. The mean is value minus standard deviation times z. And I'm going to say that you don't have the standard deviation, you don't have a z-score, and you could use one of these values, okay? But it's too many unknowns. So find the standard deviation. We'll do B first. This is A, an attempt, then we'll do B, which is find the standard deviation. Standard deviation is upper minus lower in brackets divided by Z up minus Z low. I'm going to start here. Draw your curve. You've got the mean, and how many standard deviations to the left are we? We are 2 to the left. This is 54.4 kilograms. And then we are 2 to the right, which is the upper. That's where the 65.6 is located. What's the z-score here for this one? -2. Because I know it's 2 to the left. How many z-scores? What's the z-score for this one? The z-score here is +2. Why do I know that? It's because I know that 95% of data is located, or tells me that it's between -2 standard deviations and +2 standard deviations. So let's figure this out. Standard deviation is upper minus lower in brackets. Make sure that's in brackets. Minus, what's the z up? The z up is 2, correct? 2 minus, what's the z-score of the low value here? it's -2. So you got to watch out that the two negatives meet like that, so it's actually positive. Standard deviation, let's do the top here, 65.6 minus 54.4. That's 11.2 divided by, this is actually 2 plus 2, which is 4. So all we do is divide that by 4 and we get 2.8 kilograms is the standard deviation for this set. Let's go over here now. The mean, you can choose. If you choose 56.4 kilograms minus, we now know what the standard deviation is, that's 2.8. If you're using this value, 56.4, then you have to use the z-score that goes with 56.4. Sorry, did I get that wrong? I made a mistake, didn't I? This is 56.4, not 54.4. Sorry, guys. Can you change that? Good catch, good catch. That's 9.2 divided by 4, which is 2.3. My bad. 2.3, 2.3. Sorry. So I know my standard deviation now, that's 2.3, so I'll plug that in here. So it's 56.4. Sorry, even here you got to change that. 56.4. That's the value I'm using. So it's going to be minus the standard deviation, which stays the same. And now you got to use the z-score for this value if you're using that one, which is -2. Okay. So x bar is 56.4. And if you have negative and a negative, that turns positive, right? Whether you do that on your calculator, but that's what it ends up being. So 56.4 plus 4.6, that's 61 kilograms. That is the average of this set. And this is the standard deviation of the set. Okay. I will say this on your in your question, or under this here, I will always say start with this. Start with standard deviation every single time before you find your mean. Okay. I'm going to leave that there for now. I'm not going to do C and on, just these two right here are the ones I want you to focus on. How do you find your standard deviation and how do you find your mean? I'm just going to add this to your notes here, if you can copy this one down. Or you could have used this 65.6. 65.6 minus this standard deviation is 2.3 still, but the z-score for 65.6 is 2. Okay. It's positive 2. And we knew that because of the 95, right? That told us that these values, these numbers we were given, are between 2 standard deviations to the left and 2 to the right. So this is 65. You know what? Just type it in one shot if you want to do it that way. If you're wanting to do this faster, 65.6 minus 2.3 times 2, that's 61 kilograms. So you can use either value you're given. You just have to make sure you use the z-score that goes with each of the values. And I'll also highlight my z-score here, that I've not z-score, the standard deviation here, and that's what I'm using to calculate those. And maybe it is worth saying, hey, the z-score here is -2. That's why I use -2 here. And the z-score for the higher, the upper value is +2. That's why I used +2 there. But regardless of how you do it, you still get the same answer. Let me just try one more thing. Okay, let's try one more here, 53. I probably spent too much time on the one I just did, so I'm going to show you how quick this actually can be done. The mass of Appaloosa horse is generally in the range of 431 kilograms to 533. Highlight this part here. Generally also means the majority of the cases. You can replace that with 99.7% of the time. Okay, so in this case, they don't actually give you a percentage, but you should be able to translate that to that. 99.7, write that down, 99.7%, that tells us that there are 6 gaps between values. You know that. Okay, 99.7 is 3 to the left and 3 to the right of the mean. So that tells us that 431 kgs, right, kilograms, has a z-score of -3. Whereas 533 kilograms has a z-score of +3. We know that just by looking at the 99.7%. It goes from -3 to +3. All right. Assuming that is normally distributed, determine the mean and the standard deviation. Start with standard deviation. Please always do that first. Standard deviation asks you to take the upper and subtract the lower from it, and then go z up, which is 3, minus z of the low. So you go 533 minus 431, so it's 102 divided by 3 plus 3 is really 6. So you're dividing 102 by 6, which is 17 kilograms. That is your standard deviation for this data set for the horses in this case. The mean, use the formula. You pick. Do you want to pick 431? Sure. You go 431. I need to peek at the formula as well. Minus standard deviation times the z-score, which is -3 in this case. And you can honestly just type this in one shot if you use brackets. 431 minus 17 multiply -3. And so it's 482. So based on the information we're given, we now know that the average weight of a horse is this, and the standard deviation for these horses would be, for their mass, is 17 kilograms. Bingo. Right? So you choose how you want to do it. I'll do one more. This one, it says Raven and Dion are in the same applied class. Raven scored 62% with a z-score of negative 21. This goes together, right? A score of 62 gets you a z-score of negative 1.24, which means you're below the average, by the way. Right? Raven scored below the average. Dion scored 83% with a z-score of 2.49. What's going on here? Well, think about it this way. 62% has a z-score of negative 1.24, whereas 83% has a z-score of 2.49. So it's just like before with the horses, we had two different weights and the z-scores. But Mr. Dirksen, they didn't give us the z-scores. Yes, they did, just in a different way. I told you 99.7% are within them, so you knew it was negative 3 to 3. In this case, the z-score is provided. So I would say this, find the standard deviation first. 83 minus 62 over, make sure that's in brackets, z up minus z low. Okay. And you just click this, clickety click, right? That's 21 over. You got to be careful with the signs here if you want to get this right. If you're careful with the signs and you put brackets in where they belong, you will be fine. Okay, so it's basically 21 divided by 3.73. That's 5.63. What are we at here? That's percentage because their scores are stated as a percentage. And now you can do the mean. Let's go with Dion's score. So his actual score minus z times whatever the, not z, standard deviation times the z score for this actual score, which is 2.49. 83 minus 5.63 times 2.49. This is 14.0187. So the average is 68.98% for the class. So if you want just some review questions, I would say 54 all the way to 56. But that's not. There you go. I'll give you some ACs to practice. They're not going to be for you to actually hand in, just to review a little bit for the quiz. I'm going to post the keys as well. But if you want to practice what we just did, right next door, 54, and then a little bit of creating frequency tables and whatnot, the following pages. Okay. So what's on the quiz tomorrow? I would say everything up until this point. So the take-home AC was to review everything you needed to know for the quiz. There's going to be one question like this on the quiz as well. So if you recognize that this is what you need to do, you'll be fine. So just make sure you have those formulas on your study sheet and you will be okay. All right. I'm going to stop here.